Yeah, so let's get started. So, welcome. Thank you for attending the XRStand, the first international workshop on standardization in XR. So, this workshop is chaired by Johan Hanchi from UCF and Sonji Kim from KAIST and Yosuke, it's myself from ICE. And this workshop is a half-day workshop. So it starts from now and finish at 5:30 p.m. So let me introduce and say welcome and the introduction about briefly explain about this workshop. So this is a first workshop on the standardization in XR. One of the most important motivation of this workshop is that Standardization Committee in ISMA 2025 has been established to strengthen the continuous contribution between the academic research and the standardization effort. The committee aims to promote the development and examination widely adapt the standards among with the standardized tools, methodologies, dataset, and benchmark. Standardization efforts can contribute not only ensure legal and interoperability in XR domain, and also to bridge gap between the academic research and social implementation. In order to advance the mission and the vision of the Standardization Committee, this workshop, the first workshop on standardization in XR, is held. All related research related to the standardization are welcome. Main topic of the interest include proposal, case study, or report on dataset, evaluation metrics, benchmark, or competition that supports XR research and development. The activities including, and also we deal with the activities involving the open source project, API, and tool that advance interoperability and productivity across the XR application. I think some of the attendees might attend the ISMA 2024 panel related to the standardization. As discussed in the such panel, the terminology definition, taxonomies, conceptual framework XR is also important. And also, we deal with forum standards, de facto standards, and de jure standards, and their role in the shaping the XR system. So here are committee members of the Standardization Committee at ISMA 2025. Takeshi Fukurata, John Nelson, Christine Ferre are chair of this committee, and general chairs of this XRStand are also members of this committee. So we are looking for the new member of this committee. If you're interested, please let us know. Here's the time schedule of today's workshop. At section 1, we introduced the welcome and introduction by myself, and opening remarks will be given by Takeshi Kurata, and the keynote speech will be remotely given by the Christine Ferre, and then we have the lightning talk and the poster session. The poster presenter will give the lightning talk in just 3 minutes each, and then we have the poster session. After the coffee break, we will invite two invited talks. One from Mizuri Smith from the Auburn University, and Takefumi Hiraki from the cluster in Japan. And then we will close this session. And at the end of the closing session, we will have the group, we will shoot a group photo, so please keep staying in this room. And that's all of my work. So let's move on to the opening remarks from the Takeshi Kurata. Thank you.
Thank you for your introduction. I'm Takeshi Kurata from ASD Japan. So now I'm gonna talk about revisiting historical ties between ISMA and the standardization about for 10 minutes. Okay. This shows the structure or relationship of the stakeholders involved in the formation, dissemination, and the maintenance of terminology. But such a structure is really similar to the other types of standardization, like various kind of guidelines or performance evaluation, or some other like APIs or something like that. Then today's my focus is basically sorry, this is okay. Basically, that's the rectangle part, the relationship between academia, I mean, especially ISMA, society, and SDO. SDO means the Standardization Development Organization. And today, we little bit focus on the digital standardization, like ISO, IC, JTC1. Okay. Then here shows the the lineup of the past event and the current event in ISMO. But this is based on my own research, so it's not so might not be the exhaustive. So if you know of other events that should be included in this list, please let us know. I'm gonna update this kind of data. Okay. Then the red so items are actually read by Christine Perret. She's actually the keynote speaker of today's event. And now also she's one of the chair, as Ryosuke mentioned, the chair of the standardization committee in ISMA 2025. Okay. Then group events are organized basically by the jury team, and those topics were basically for the reference model of MAR, mixed and augmented reality. I will talk this later a little bit more. Then the trigger was the trigger of today's activity is that panel XRStand around XR. So held in last year's ISMA. Then, as Ryosuke also said, in this session, we discussed lots about the terminology. Yeah, and actually, one of my poster will introduce these findings later. Okay. Then I'm gonna move on to the gradually relationship between SC24 and ISMA. Actually, today we have the SC24 chair, Myung-won Lee, as audience. Thank you for coming. And then actually we have so many participants, not many, but not a few participants from ISMA community to SC24 for developing standards. And also JTC1. JTC1 is a joint technical committee on IT in ISO-IC. JTC1 encourages each subcommittee SC to increase the contacts with consumer groups or some other external society. Last year, I thought it's good to create so some committee in ISMA to deal with standardization. So the one of the trigger was that the panel last year, but another trigger or motivation of myself is that something like this. So we established the standardization committee this year in ISMA 2025, and also organized this workshop. And let me a little bit introduce what SC24 is. The title of the subcommittee is Computer Graphics, Image Processing, and Environment Data Presentation. And that sounds a little bit old, but the same thing happened in IEEE, like IEEE VGTC and IEEE the TBCG. So those sounds familiar, but sounds a little bit weird these days because you know, the computer graphics and visualization isn't all for our community. So the IEEE guys also now trying to change, update the title, but there are so long history and the legacy that is same as the digital standardization. So we also really have difficulty in changing the title anyway. So, but it's really small, but if we deeply see the structure of the working group in the SC24, we can see the virtual reality, mixed reality, augmented reality. So we are changing the structure so under the sea. So then finally we would like change the title of SC24 anyway. So now we are collaborating. We means the ISMA community now collaborating with SC24. So, but it's not so big wave. It's really so small wave. So I wanna get this bigger and bigger. Then I'm running out of time, so I will skip. Okay, then this is one slide from the ISIC workshop about the standards for the metaverse standards and the project by SC24, made by Myongori. And in addition to those standards, historically, SC24 have developed and maintained PNG. I think many of you know the PNG. PNG or VRML. Those standards are developed in SC24. Okay. Then under SC24, there's a W9 on MLR. Then actually, I was a project leader of the standard on benchmarking of vision-based spatial registration tracking. And that one is really relevant to ISMA activities, especially the tracking competition. Maybe you look very young, so that you don't know that once upon a time, ISMA community had such a competition events every year. Anyway, so based on those experience, we developed a standard for benchmarking of performance of tracking method. That basically almost the time, yeah, to finish my talk. So actually, from this standard and also from this list, we realized that, okay, so ISMA community has a long and continuous relationship with the digital standard. However, or any kind of standardization. However, it's not so, as I said, it's not so big wave, but it's really important so theme or issue to be handled, especially because of this structure, especially we need to fight with the technology promoters. It's really powerful and influential. So to do that, we have to, make the big group in that right circle. Okay, so that's all. So this is like the how to say introduction, maybe introduction of the Christine keynote speech. Okay, so I will change the. Okay, so Christine, now it's in the morning in Switzerland.
Yes.
Okay, okay.
Hello. Yes,
Hello.
it's a fine time of the day. It's absolutely great.
Yeah.
Thank you for your introduction and for inviting me to this event. Just a second. Let me get back to my. Can you see my screen?
Yeah, now we can see your screen.
Okay,
Let's-
very good.
let's
Thank
start.
you very much for your yeah, hold on. I think my screen sharing is paused. I want to have it be okay. Thank you very much for this introduction and for the context. I have some things to say about the topic of terminology, but I think I would best begin with the planned remarks. For those of you who don't know me, I'm an independent consultant. I do market research and I'm an advocate. That means that I'm one of those people who cares very strongly and who has a voice a little bit in the subject matter of standardization and interoperability. And I'll be talking with you about several projects that I've done just this year and that I hope will be of interest to you. So, as I said, I'll be talking about the standards landscape that was published earlier this year. In fact, an update is scheduled for this week. So I will try to send out a updated URL. And a study that I did building upon the standards landscape. I'll talk about what I think are some of the important agencies and why we have hope that this will be there will be improvements in the future. And let's talk about, what we can expect in a few minutes. All right. So there was a project from the European Commission and the European Fair Trade Association, a jointly funded research project to bring standards make them more visible. I want to start off by saying that the term virtual worlds is what the European Union has chosen as the term for the metaverse and XR and all of the topics that we share an interest in. And I think this very well illustrates the problem that there are many, many terms that mean the same thing. In this case, virtual worlds is very large. The scope includes virtual reality, digital twins, augmented reality, of course. And so there's a lot of complexity in this question of terms, but we wanted to make sure that people could find the standards that they were looking for if they were looking. We don't try to explain why they would be looking for standards, why they are important or beneficial. In the second part of our research project, we provided extensive recommendations to the European Commission. Those are confidential, and we hope very strongly that they will be followed. So I'm going to tell you a little bit more about this project. The way we defined it, and this comes right exactly to the topic of terminology. We were given some structure by the European Commission already, the baseline structure, and I don't think there's very much debate about data management and infrastructure being the foundations for virtual worlds or the metaverse. And then on top of that, the question was, how do we divide these different blocks? In this figure, you can see that they overlap slightly, and this is a signal for everyone who studies this domain, these topics, that it's difficult, and in fact, it's impossible to perfectly remove all the topics from one domain and keep them all in another domain. There's a lot of synergy, I could say. There's also some other problems, which I'll come to in a minute. But you can see on the right and the left-hand side, what we're saying, this text, experience creation and delivery, is that in the middle bar is where content is being created and shared, and the top is where the use cases are. In each one of these 8 domains, there are these things we call components, and each component has topics. This became, I don't know, it's almost 30 pages of the report just to describe these blocks and these terms and concepts. And the way we define these was starting off with our own personal knowledge, and then we used large language models, and we iteratively improved them until we were very confident and the definitions were stabilized. We asked for input and review from other experts. Once we had the definitions, we had a baseline of set of standards and SDOs, and we collected more. The database went from about 580 to something close to 1,700 different entries, different records in our data set. So we expanded very greatly using the method I have on the right-hand side. And this allowed us to really have a high degree of confidence because we have high numbers. And we prepared summaries. We didn't manually prepare. We had the privilege of having the original documents from all of these standards, with the exception, I think, of about 5 standards. And we put these into the LLMs. And we developed proprietary and specialized large language models in order to understand the terminology and the topics that we were studying. We created summaries of all the clauses of all the documents. And I'll tell you that in one of the most important standards, it was 1,700 pages of the original document. We boiled that down to just 20 pages of summaries. So this is a very, it's a big data problem, and it's an analysis that was very, very robust from a scientific standpoint. I've already mentioned that this data set became very, very big, very rich. A lot of information was manually entered. Of course, that can introduce errors, and we had to do corrections. We had to do verifications, and then we could compare all these standards with the definitions of the domains. Now, this is still going on. The data set is still being enriched and improved all the time. Let me get to a few of the things that we found. First of all, we were able, through this process, to identify that there was a very big difference in the countries of origin of the Standards Development Organization. As you may know, many internationally mandated standards have their headquarters in Geneva, the ISO IEC, and others. And so many were, this is why you have the red bar on the left-hand side. But what we found is many industry-driven standards development organizations have their headquarters in America, even though their standards are intended for global adoption. So there were other differences, the number of working groups, the pace at which these working groups were working. Again, because of the size and the richness of the data, we could sort through many, many differences. The publication types by SDO, the tools that they provided, how many people were involved in the standards development organization. This is very, very robust, and I invite you to look at the study to get more information. One of the things that we found is that over the course of the 20 years in the figure on the left, the data management and infrastructure are very important topics. There are many, many standards in this area. And new documents are being published every year. So you can see that in 2024, there were close to 50 new standards just in this subject of data management that could be relevant to the virtual worlds. On the right-hand side, you see one of the figures that we have, and this is an interactive figure. We have chosen in this particular illustration to show you the data management standards. That's all the orange dots that are close to the center of the topic of data management. That's close to the star, or if they are close or if they pertain to any of the other domains. And since we have many, many dots in the middle, what it's saying is that there are many of these data management standards that also pertain to other subjects in virtual worlds. And so they are what we call cross-domain standards, which can be beneficial, can also be an obstacle. I don't want to spend too much time. Again, this is another way of looking on the left-hand side at all of the different domains and how different standards are populated. Again, it confirms that data management standards are more than 1/3 of the data set. There are also 20% of the data set is in infrastructure, and then you see the other categories. What's probably most important is that you can download this report and evaluate and study it yourself. The project itself has its own website, and I maintain that. You can browse the page for, as I've show you a screenshot on the right-hand side. This is the ETSI Industry Specification Group for Augmented Reality Framework. They have many publications. You can download the report itself, the PDF. But probably, as researchers, I recommend that you also access the supplement. The supplement is a zip file that has, I think, somewhere like 56 different spreadsheets in there. So you can really, really go far. I mentioned that one of the deliverables of the project was to recommend the certain steps be taken. And this is the top recommendation, that standardization is not finished. It must continue, even though there are 1,000 different standards potentially relevant. We are lacking and we have gaps and problems because data management is a very fragmented subject, and there are many, many gaps. And there are especially a lot of conflicts because with so many standards, somewhere up of 180, I think 190 standards, many are conflicting. There's also a gap, a need for spatial temporal, so geospatially anchored ontology, spatial perception, scene description. These are all gaps that are not filled. And there are many industries that are important and into which virtual worlds and XR technologies will be going. We don't have standards that match those industry-specific requirements. We also need to emphasize more standards for privacy and protection of users. But even if we have 1,000 or 8,000 standards, not all standards have impact. So I took the data set that I've spoken with you about, and I built on that. I went through and I created with my colleague a deep research agent. And we used that agent to analyze 19 companies. And the purpose was to see who and which companies have implemented which standards. And the question really is, does anybody adopt the standards we've identified? We used, a lot of computing power and produced a lot of individual reports by domain, by standard, and by company, and prepared some tables. Just to give you a flavor for what this covered, these are all the different companies that we studied and the 5 different provider categories that they're in. You can see that many, many of them, the majority produce tools and engines, and that's critical for interoperability going forward. So what did we learn? The most widely implemented standard is also one that's very familiar to all of us, 802.11, for connectivity between devices and computing power. These other standards are also important. They are implemented widely by the major providers. But why only 4 out of hundreds? Well, because many standards were developed without the stakeholders at the tables, the requirements that they needed to match, they were unknown at the time, and they're probably still unknown. So this is a very, very important mismatch between the standards that are proposed or even ratified and the requirements. There's also very, very few situations, except for those 4 up on the top of this screen, that went through testing and demonstrations. Very few standards have the tools and documentation for developers to follow. Many standards require a fee just to purchase and download the standard, and then there are royalties to use them. And finally, a standard isn't a standard until it is widely implemented. So those are some of the key takeaways. We also know that there are very, very few customer segment stakeholders involved in standardization. There's not very many layers or abstraction layers that are defined between the different sections in the stack. Big companies don't need standards because they build and use their own proprietary technology silos, and they're extremely resistant to the use of standards. So it's not a pretty story. I invite you to download the full report. It's free. There's absolutely no issues for that. After my talk, I'll be happy to put all these URLs into the chat of the Zoom, and you can share them. I'd like now to talk to you about the Metaverse Standards Forum, because this question of too many standards is also, I highlighted for you how few stakeholders are involved in the process of standardization. This organization emerged 3 years ago from Kronos Group. It was a Kronos Group project until it was demonstrated that it was much bigger than one standards organization, because interoperability is a requirement. It's foundational to the growth of these industries. We need it in order to have diversity and integration of spatial computing, the web, and we will require many, many standards, perhaps not 900, in fact, certainly not 900. But we need to have coordination between all the standards organizations and their working groups. This is not another standards development organization. It's a coordination activity. We discovered within a few months of starting this organization that many, many companies were interested in this topic. It's free to join, which you could say is not a barrier. And that's an important criteria for participation. We don't want to put up barriers. We want input. But there were thousands, and there still are thousands of companies that are members of the Metaverse Standards Forum. The blue in this pie chart on the left is for the Americas. There are hundreds of companies in South America, hundreds in North America, and it's approximately balanced with Europe, the green zone. Yellow is Asia. So this is a really important sign that we have global distribution and participation for a wide consensus about this topic. And there's really strong involvement. We have about 30 big companies that have joined at the premium level tier, which is a funded level, and they are participating in our growth. So why does the Standards Forum appeal to people? Because it's a coordination activity to help the SDOs find their ways out of this nightmare that they are in today. So we're helping them with pre-standardization activities, identification of use cases and requirements, as well as development of testing and tools and providing feedback after the standards are developed. So for the first few years, we're primarily, I would say, in the document examination phase, looking at many standards. There were 16 or 17 working groups created. And some of them produced reports, many of them identified use cases, and it was very much of a document-centric process. But about a year ago, we started working on this new initiative called the Forum Labs Initiative within the forum. And the purpose of it is to turn some of these requirements into implementations, to actually connect those stakeholders that want to see the standards with live tests, test beds, and plug fests and demonstrations that are real, that are code-based. And so I'm emphasizing this because I believe many people who are interested in standards at ISMAR are also engineers and could be involved in labs and research facilities that would be interested in becoming a forum lab. To the forum, it's scalable. There are thousands, maybe tens of thousands of laboratories worldwide that share our goals. They have the idea of working on reality, real world outcomes. So we think that you'll find new research challenges. You'll also identify partners for future collaboration through the Forum Labs initiative. We also are looking for sponsors that can understand and new opportunities for implementing standards in their products and services to reflect their industry leadership for interoperability. Standards development organizations can receive feedback about what they've already ratified, as well as clarity on what is needed in the future. And everyone will benefit because we'll have interoperability. So a forum lab can apply, and then if they meet our criteria, they'll be designated and have this badge on this Forum Lab Principal Labs badge. Then work in collaboration with our working groups to define new projects and then execute those and publish the results. Those are opportunities for you. But I want to highlight that not only researchers and SDOs are involved in this process of standardization. Probably, in my opinion, the most important is the customer segment, because if customers don't ask for standards, then the large enterprises will never implement them. And so what I've seen this year in 2025 is a pattern of companies, large enterprises in defense, in oil and gas, in heavy industries, in governments, US governments, European governments, elsewhere, that are asking for interoperability, even requiring it in some cases. This is a very, very important sign. They haven't, let's see, been widely heard yet, but they are beginning to voice their needs. I also think that over time, we need to fill in the gaps, not create standards where there are already standards. In fact, we need to remove standards that are out of date, and there are many, many of those, or standards that did not match the requirements. We need to continue to look at industry-specific standards groups in order to explore how they can expand their scope to include virtual worlds. And even if we have the best standards available, there isn't a requirement or even a professional institution and institutional guidelines for leaders to mandate and to request interoperability, for engineers to implement these standards. There's a lot of gaps in education. So the customers are coming forward. Maybe they are going to be able to describe their requirements. And I think this last bullet is super important. We need to have governments that will say, we will not purchase products until standards are implemented for interoperability. That will go very, very far in driving industry growth. So I hope this talk has shared with you that there are many, many standards. I'm reluctant to encourage people to develop more new standards unless they are in the specific areas where we know there are gaps. There are going to be many standards required because of the different dimensions of the metaverse. It's vast. There are many layers to it. And there's very low evidence that we have made much of a difference so far, but we could have hope that in the future, these proprietary technology silos, which today are closed, could open and give us new opportunities. Otherwise, I don't know that this industry is going to survive and grow as it should. So I give you back the floor. Thank you for this opportunity. I hope this talk was interesting for you. Are there any questions?
Thank you so much for the okay, so we have around 10 minutes for discussion. Any questions or comments? So if you have any question, please come to this speaker microphone for network conference. Any question? Yeah. Yeah.
Yeah, can you hear me?
Yes,
Yeah,
very perfect.
Here or
Maybe if you stand around
It's
here,
here,
then
right?
she
Oh.
can.
is it clear or?
It is very clear. I hear you
Okay,
perfectly.
yeah. Yeah, this is Sunsi Kim. I'm from KAIST Korea and one of the member of standardization committee. And thank you for the great talk. And I have a short question. Like you mentioned about the voice of customer. So in that perspective, I think the academic side also have to consider the voice of customer when they are developing the technological methods or solutions. So do you think what kind of like practical solutions or systems are needed to achieve this purpose?
I think the customers, you're asking me what are the customers' requirements?
Oh, I mean,
They're
like,
highly diverse. I mean, they depend on the industry, they depend on which, what the subject or the use cases are. I think, here's one of the things I'll tell you. There's something called, the single truth of data. So many companies store in their infrastructure information about the people, the objects that they own, the machines that they use. And they know exactly the year they were built, when they were maintained, great amounts of detail. And what they want is to be able to visualize that information. They don't want to have that information be imported. They want a single pipeline of truth and data that is never interrupted. So we're at the very end of a long pipeline of information, and visualization is something that the human needs. Machine doesn't need the visualization, the humans need it. And so we want to be able to directly view what is in the data set for a particular task, inspection or performing assembly or something like that. So this is one of the requirements that is currently not met. Today, the data, and this is back to the data management topic, the data have to be imported into some type of a content authoring tool, manipulated so that there's a low complexity, and then further changed and modified. So if there's any change to the data at the origin, in the data set that owned by the company, it's not reflected in the final experience. That's an example of a requirement that's felt across all of the large companies that would potentially use VR or AR.
Can I ask you? Yeah. So yeah, thank you for the answer. And especially about the academic side, how can they also consider those kinds of various voice of customers in their research projects or
Okay.
their
Yeah.
research?
So I think one of the key fundamentals is never have a project if you don't have a customer involved as a partner. That would be my recommendation for research organizations, is always have a customer, large or small, involved in a research project. What is the problem that is being addressed? Many times the problems are invented without having a specific customer in mind. And that customer should be representative of an entire industry. So that would be a very, very important recommendation, is have a customer somewhere in your project, a use case that is validated and where you can actually test under real world conditions.
Yeah, thank you for the answer.
Thank you.
Any other question?
Thank you for great talk. So I'm Takem Hiraki from the clustering University of Tsukuba. So I have some research position at the metaverse platform, and I'm also has the academic position in the university. So I know both the positions, the benefit and the troubles, and from the side of the platform. So my question is about the interoperability. So from the side of the platformers, so the platformer is trying to make the growth own platform, metaverse platforms. So and in that maybe XR platform. So in that case, so they do not thinking about the standardization or the interoperability from the other rival platforms. So, but for the academic researcher side, so that we trying to make them as connected each other and trying to growing the ecosystem of such kind of XR platforms. So there is a very huge trade-offs of the private company and our academia and standardization forums and standardization persons. So I'm frequently wondering how to solve this kind of the dilemma of these two positions. And so, and for example, if the connecting the very two platforms, so but the users is trying to moving another platform very easily, so that is the very not good things for the platformers.
It's a paradox.
Yeah,
it's a paradox. And
Yeah,
you
do you have
expressed
any
it
good
very
idea
well.
about that? Yeah. I want to ask about that. Yeah.
Yeah, I think you never mentioned the role of government and regulation. There is a possibility, not that there be regulatory requirements for interoperability, but that purchasing by governments would require interoperability. Probably that's where right now I think the most potential lies, where any government, and if I could make another point here, in the last 24 months, okay, maybe longer, the biggest purchaser, the biggest industry for augmented reality and perhaps virtual reality, I'm not sure, is defense. It's war. Okay? So people are using these technologies for military applications. The day that the military or the government who's purchasing these technologies says, I need interoperability, everything will change. It's not a question of the government defining what interoperability means. They'll just say, I have to have it. That will change where the research funds go. It will change how those large platforms behave. And it will also mean that any product that's purchased by a government could interoperate with the industrial side. So I don't like to bring this up. I don't like war. I don't like the fact that our industry is dominated by military spending, but it's a fact. You may not see it in your research, but I can tell you that many companies, if they have a defense contract, they survive. If they don't have a defense contract, they die. That's the difference. So, in terms of research, there are some excellent collaborations that can happen between military and scientific laboratories and groups. So, I regret to put such a fine point on it, but that's really where it is. In Korea, one of the things I know is the shipbuilding industry is really a big adopter. And also they sell to, other industries. So I know that very heavy industries are the most likely to require interoperability, in part because they have this digital source of truth, and they have the very heavy industries, and I'm here, transportation, mining and metals, many oil and gas, energy. They are controlled and they are managed by regulations. And in some examples, even the military regulation says you can't buy from just one provider, because if that provider fails for any reason, then the government is in danger. So these are where the opportunities lie.
Okay, thank you. Yeah, I completely understand situation,
It's not pretty. It's not roses and, peace and love. No.
Thanks so much. Unfortunately, we are running out of time, but for a short period of time, we could have the fruitful discussion with Christine. So let's thank the Christine again. Thank you so much.
Maybe the order is written in the website.
Yeah. Do you remember your ID? From 0001 to 010. Okay, but yeah, I will show you the slide one by one. So if you recognize it's mine, then please count.
So we kindly ask the first presenter to keep the presenter in 3 minutes.
Okay, thank you very much. I'm the first presenter. Our talk is about the benchmarking the localization system that collaborates with the navigation robot and the smartphone. So as a background of this benchmarking, the support for orientation and mobility for the people with visual impairment is quite important, and there are a lot of technologies for that. So, for example, there are smartphones to navigate the people. They do not limit the user's mobility, but it can be inaccurate in orientation or location information. So if we want accurate location, we have to invest into the equipments, and also we have to maintain that kind of equipment or data set. So this is very costly. And also, right now we have emerging technologies like navigation robot right there. So they pulls the user's hand towards the destination, and they have a lot of sensors and computational resources, so they can have precise location. But it can restrict the user's mobility, such as they cannot go upstairs. So combination of these methods enables complementary navigation. But we don't have this kind of data set out there, and also we don't have similar systems. So we organized a competition using this data set. Okay. So the scope of the competition is that we assume that the navigation robot is available in a target venue. Actually, this navigation robot is operated in the Japan's museum, and it's currently working in the expo that ends in this week. So this is a kind of future, but it is kind of realistic. So the purpose is to estimate a smartphone's location heading. So the smartphone is one of the user, and we are going to estimate that location and heading. And approach is that we have a navigation robot. We don't want to invest in the environment, so we just put UWB tags. UWB is ultra wideband, and we have the smartphone, and they also measure the UWB measurements, so they can get the distance and direction of the UWB tag. So with this condition, the user moves with the navigation robot to the destination. They leave the navigation robot and they experience the exhibit, and then go back to the navigation robot and go to the another destination. So this is the situation, and we took some data set with this situation. So this is example of the experiment. The user is using a navigation robot inside a museum, and he has a smartphone on the neck. So in this situation, we took data set and the ground truth, and we hold a competition. And there are 4 competitors for the competition, and here are the samples. So let's talk about this kind of benchmarking and further development for this kind of.
Again, this is Takeshi Urata. On behalf of Iwaki-san, I will so present the poster titled BRM Concept and the Implementation of an Application Interoperable Avatar Format. Okay. BRM is basically currently the forum standard on avatar format that enable cross-platform connectivity and collaboration in virtual worlds. And there are several unique features. One is that the BRM includes its intermediate layers for emotion abstraction constraints for animation control, such as gaze control or facial expression. And another feature is the viewpoint setting, which are optimized for immersive first-person VR usage, and format that integrate licensing information with personality right that enable creators to govern or control how avatars are used and represented. Then now the current situation is we in this case we means the VRM consortium, the Kronos group, and ISO ICJTC1 now developing the or making the VRM digital standard in JTC1 as a GLTF extensions. So please come to the poster, maybe right there. Okay, thank you. So.
Hello, my name is Minuso from KAIST, and I'm going to talk about there is a very critical trade-off between accessibility and expressiveness in the standardization of social VR contents we found from social VR domain. In our research, we identified there's two categories of social VRs, which is inclusive and exclusive. And it's very interesting that because inclusive social VRs, they concentrate more on making users participate. So they allow a high degree of freedom to users to create their content. How freedom? You can write a RISC-V interpreter in GPU, so you can run Linux on GPU. That's how freedom they provide. On the other hand, exclusive social PR platforms such as the Meta's Horizon Worlds, they don't really focus on including user participation. Instead, they provide content to users, so it's far more accessible. But actually, in social PR domain, we kind of value inclusive social PR more these days because we can see how different people participate in social PR in very wide range of freedoms. And we found a very interesting trade-off between expressiveness and accessibility in those two categories of social VR. And inclusive social VR has to be very highly expressive, which means users can make a very wide variety of contents into the platform. But it requires some amount of expertise to users. So people have to have knowledge about, for example, USD and other rendering systems. But instead, exclusive social media platforms such as Meta Horizon Worlds, they provide platform-specific content description, so it's far accessible and far more editable in game, but it does not give you a lot of freedom. And this kind of trade-off is very interesting because the simpler you make, the more users will understand it and more users will participate in it. So you can lower the barrier to the virtual reality. But on the other hand, if you want to be more expressive, then you can let users participate in more complex and more enriched content creation. But you cannot really bring in a lot of users because not every user can be an expert in VR content. So where is the balance? And we found a very interesting case of a balance, which is VR, and also as the professor already mentioned. And VRM is a very interesting case because it's mostly used in inclusive social VR platforms. So they try to be very expressive, but also they have to be very simple in terms of users because they are not only expert users, but they are also a lot of just light users in social VRs. And to find the balance, the VRM went through a long-term iterative design process. So they provide users access to very high-level concepts, just like simple UI-based editors, but also they give you freedom to modify all the generative-based low-level graphical contents. And VR is now widespread in social VR domain, especially in the industry in Japan. Okay. And what should we do is we have to do very good requirement engineering for finding the balance, especially in social VR domain. And for the future research, I emphasize the importance of making a platform that includes a different level of expressiveness and expertise to allow a wide range of applications and user participations. And I'm also doing a web kind of collaboration. And if you're interested, then please go to me and we can talk more. Thank you.
So hello, I'm Kyung-Min Kim from Jong University of South Korea. I originally prepared a lot of things in the presentation, but let me be short. So basically what we do is standardization about the hand and finger gestures, because hand gestures in touch device has own term, but normally in the mid-air gestures are not mid-air gesture has well standardization about their own gestures and their gesture tones or the other format for gesture description. So we made the human finger code framework. It's consisting the three parts: the thumb and other fingers, and the optional X flag. It's about the depth relations. And things I need to introduce you is a thumb movement. There are a lot of thumb movements and other finger movements, but we simplify the only few movements of thumb and other fingers. So for thumb, there's a 3 axis and 6 DOF. Distinguished as opposition, abduction, adduction, and flexion, extension. So we made several levels of movement, and you can check the 0 from 6 as a 7 levels. And for the other fingers, we distinguish the finger flexion levels as a 4 stage, the 0 to 3. The 0 is a default mode, the straight digit, and and 1 is slide bend, 2 is half close, like a C curve, and last one is deep bend, like a fist gesture. And last one is a X code, like the image in the slide, like crossing the fingers. So the X code represent crossing or inserting gestures. So 0 is a default mode, so you don't have to specify it as a format. And the other and next one is crossing motion. 2 is multiple complex crossing. So when you cross the middle finger and index finger, you can cross the other, like the rest of the fingers, so you can specify it those at the same time. And the last one, the 3x3 is inserting between. I will introduce this example later. Example of X code, the R. This is the American Sign Language for your information. So R is the index finger over middle finger. So when you specify it as a human finger, the thumb movements and the other fingers flexion levels, and the last one is the index middle, the X1 level, and then the K hand shape is the inserting motion, and the human finger specification is thumb, the other fingers flexion levels, and the last one is thumb, index, middle, X3 levels. So we covered all American Sign Language with the 3 codes. Yeah, there's a lot of there's the full human finger code, but you can check in our paper later. Yeah, to sum up, we propose compact human readable notation for cross-platform XR and the full ASL coverage with minimal symbolic complexity. Thank you.
Yeah, good afternoon. My name is Leon from KAIS, and the topic I'm going to present is spatio-temporal mixed and augmented reality experience description for interactive playback. Oh, it's not working. Anyway, I believe most of you guys have watched the Ready Player One, and
it's where Halliday and Morrow started gregarious games.
the idea from this.
These days, reality is a bummer. He showed us that we could go somewhere without going anywhere at all. You don't need
Like something. Maybe we can just go to the next one. So when we capture this experience and what if we can
Yeah. Oh, great. So we're wasting time, but anyway, the key idea what I want to do is when we capture some spatial temporal experience, and we in the future with the AR glasses, we can experience it not only just perceiving passively, but we can interact with the character or the scene. So what I want to do is how can we represent the data for that interactive playback? So it can be used for like this, like cooking scenarios. Nowadays, when you want to learn some cooking, we have to just play and pause all video clips and follow each step, but according to some of our skills in the task, how we proceed, it can adaptively play in timeline. And also we can ask a question to the NPC in the scene. So what I want to do is represent the data with a scene graph for interactive playback. The first term I developed is the event primitives, which means kind of make the contextual data from this raw data. So when you capture the scene with camera and sensors, it's all raw data, but the important thing is what is going on, like someone is grabbing or moving around. So I'm gonna detect the event and make it as a primitives to the scene graph. And the next term is when we just simply all record like 60 frames per minute per second, it's gonna be too huge. So I define the keyframe primitives that can define as like some key events of this recorded spatial experience. And the last term is the playback primitives, which means from this keyframe, we can generate a scene of the key moments, and we can interpolate the data between the keyframes. And also we can check whether this is in the main branch, which is the recorded one, or the user is intended to ask some new question, which means system have to make a new branch to react to this. So yeah, like this. So if we have the original one and this user interact, and this isn't distinguished that this is not a recorded interaction, it can make a new branch and we can generate new experience with the artificial intelligence. So yeah, this is the huge flow chart for this how it works, and yeah, I can tell you more in front of the poster. Yes, thank you.
Hello, I'm Soyoung Kang from KAIST, and today I'll present a human to avatar face representation of XR glasses wearers for communication. So this item is an ongoing work item in ISO IC AWI 25767. So with the rise of remote collaboration, there has been a growing demand for tools that facilitate communication and collaboration from remotely. In recent years, immersive platforms have rapidly emerged to support remote collaboration, offering opportunities to engagement and presence by immersing users in 3D environments. These environments allow users not only to share contents, but also to feel as if they are co-located and leading to more natural and expressive communication. So in this context, we interact with others while wearing XR devices. Because these devices are partially cover our faces, a key challenge is to how to represent facial expressions of users accurately and consistently. So we focus on bridging this gap by capturing and representing users' facial features to create avatars that exactly resemble the real individuals. So in this work, we try to enhance the realism and effectiveness of communication by accurately reflecting the user's facial features and also the movements. So here's the overview of our proposed two-phase framework for standardizing avatar-face representation. So the first part, shown in A, the upper part, is the offline phase, which includes facial data acquisition, 3D model generation, and a visual representation. So this is where we reconstruct the user-specific 3D avatar, an avatar face that reflects the person's unique structure and also visual identity. Then the second part, in the B, real-time phase, captures the live facial expressions from both occluded and non-occluded regions using sensors. So this is the illustration of the structure for the human to object interface representation, and this is the offline phase and the real-time phase. So due to the time limit, I try to be fast, and we can discuss more in the poster session. And if you have any questions, feel free to reach out. Thank you.
Hello everyone, I'm Christos Goumas, and together with my co-authors, we are excited to share our work on a human-centered framework for standardization in extended reality. The motivation for this work comes from the need to ensure that standards for XR evolve to serve people, not just technology, platforms, and markets. As you all know, XR today is advancing at a remarkable pace, but with that growth comes fragmentation, which creates several challenges across the entire XR lifecycle. When it comes to developing XR applications, for example, the lack of interoperability often undermines the scalability of XR solutions. Measuring performance in XR frequently relies on non-validated tools, limiting the reliability of findings and comparability across studies. Meanwhile, the evaluation of effectiveness, efficiency, and user experience, all crucial parameters for proving the value of XR technologies, remain far from standardized. Across all these stages, the human factor too often takes a secondary role. This highlights the need for a more cohesive, human-centered approach to standardization in XR. We propose a conceptual framework that aims to redefine XR standardization by placing human experience at its core, treating it as a measurable, comparable, and improvable element alongside technical requirements. This framework is built on the principle that standards should reflect not only how systems function, but also how humans experience them. The foundation of the framework is cross-sector collaboration, which supports the iterative core of the framework where standardized development, measurement, and evaluation procedures continuously inform and refine one another. The ultimate goal is what we are all striving for: broader technological adoption, research reproducibility, and true interoperability both for developers and users. At the core of this framework are three interlinked pillars: development, measurement, and evaluation. In development, human-centered design principles are embedded from the start, ensuring XR applications are shaped by user needs and values. Measurement introduces standardized tools and metrics to capture and compare human experience, while evaluations ensures these metrics are applied consistently across applications and contexts. Together, these pillars aim to shift XR standardization from being technology-driven to being experience-driven. Placing human experience at the forefront of XR requires collective action, and this is what we are here for. We believe our next steps are to strengthen cross-sector collaboration, something that is already happening, align on shared tools and methods, especially when it comes to research and development, and finally embed core values like ethics, accessibility, and privacy into standardization efforts. We believe that together these actions lay the foundation for a trustworthy, inclusive, and human-centered XR ecosystem. Thank you for listening. We look forward to continuing this conversation both within and outside this conference.
Hi, I'm Sanjit Kim. I'm gonna introduce future space representation, standardization for mixed and augmented reality, remote collaboration. So many existing remote collaboration systems, such as spatial meeting systems, or Oculus workrooms, rely on full virtual environments where avatars communicate. In contrast, our work focuses on mixed and augmented reality collaboration based on each participant's real physical space. This approach enables stronger immersion and a clearer sense of co-presence. To achieve this, the key concept is the mutual space, a shared environment where remote participants can meet and interact within the same collaboration context. It is generated by identifying and maximizing common elements between the two physical spaces. Basically, the host and client species are different and the furniture within them are also different. So the goal is to find spatial correspondences between these dissimilar species, match their shared spatial elements, and enable interaction based on those shared references. This work is now under standardization in ISO IEC TC1 SC24 Working Group 9. Our focus is to represent mutual species that support both matching and modifying, so that shared environments can be aligned and adjusted. The mutual space representation consists of three main layers: physical space data, match space data, and collaboration context data. The physical space is modeled as a hierarchical graph describing how spatial elements are organized and related. It includes four types of nodes and two types of edges. Nodes holding geometric and semantic attributes for identity, hierarchy, and affordance. Edges encode relationships, vertical for hierarchy and horizontal for proximity or function. So this figure shows data representation of two different physical spaces. The pink square highlights each space's physical data within its local context. Yep, and the match space concept connects related elements across species through geometric and semantic match. Each node retains its source reference and keeps properties, ensuring consistency between the species. And finally, the collaboration context describes how users experience and interact during mixed layer collaboration. It includes contextual factors such as participants, environment, and communication method, helping optimize and reflect the overall collaborative experience. So I'll be happy to share more details during the presentation over there. Thank you.
Yeah, I'm Takeshi Kurata. My poster is titled "The Non-Terminology, Non-Standards, No Future: Semantic Interoperability for Bridging Stakeholders in XR." Basically, my poster paper is about the summary of the key issues identified in the ISMA 2024 panel. Such as the current status of the term XR and its usefulness and limitation, and the lack of shared understanding regarding the origin, definition, and classification of terminology, and the proliferation and misuse of terms based on psychological and social background, blah, 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 blah. And the blue one, the usefulness of reinterpreting and redesigning existing terminology. This is basically really relevant to the next invited talk by Mizi, and others also important, but so due to time limitation, I skipped that. Then one thing that really fruitful in the panel is about the XR, the origin of XR. So talked by the Neil Trevitt from the Kronos group, or I forgot. Anyway, so the conclusion is XR. X of XR does not mean extended or cross, just the X. X is X. So XR is XR. So XR is a symbolic expression or umbrella notation for VR, AR, MR, VR, extended reality, or cross reality, or any kind of reality. So according to his talk, that the origin of XR is XR, not extended reality nor cross reality. And that Open XR logo shows the how they think about the how to say the design of Open XR logo. The V in the upper of X is V and the lower side is A. Or anyway, and so that my message is let's respect the origin. And next example is metaverse. The original metaverse is just right lower side, the area, virtual worlds. But nowadays, the scope of the metaverse is really getting broad. But the question is whether we, how to say, so cover the real world with just the term metaverse, or we need to coin other term. That's a question. Okay, anyway, so this is already I mentioned in the opening remark. So anyway, let's come to that poster over there. Thank you. Thanks so much. Okay, now it's time for the first invited talk of this session. So other participants, please close that door. Thank you. Thank you. Yeah. So as I told in the opening remarks, we had a panel on terminology, especially on XR in ISMA 2024, and I got Mrs. talk there, and I really feel like yeah, we need to invite her to the first workshop of the standardization this year. So then she so accepted our invitation. So thank you for coming, and I'm really looking forward to your talk. Yeah, so please, thank you.
Okay, and I'll apologize in advance. I've been a little sick, so I may have to pause to cough, but I'll stay away from you. And so the title of my talk is Revisiting Taxonomies and Developing Standards to Enhance XR Research. And I thought most of y'all may not have been there last year, and so I'm kind of gonna recap some of what I talked about there and then build on it a little bit more in this talk today. So a little background of kind of why am I here and what is my headspace in this space. It really started from the pandemic. It started from COVID, and that's because Rick Skarbas, Mary Whitten, and I, that's who that picture is of, we kind of started talking about this question of, you know, what is presence in XR? And we started talking about that in March of 2020. This picture is from 2024. We didn't actually meet until VR 2024. But we started talking about this question, and that kind of led us down this rabbit hole. And so we then wound up talking about, you know, what is AR and what is not AR. And I think that starts to get to when we talk about standards, you know, how are we defining these terms? And that turned into, you know, how is AR different from MR and VR and all of the things are. And, you know, we use this useful shorthand of AR and VR in particular. But one of the things that the conclusion we came to is that that is a really useful shorthand, but it's also limited and it's overlapping. So, you know, I think you'll probably all have an idea when I say AR or augmented reality, you have an idea of what I mean. When I say virtual reality, you have an idea, but the specific bounds and the specific assumptions that you're making as a part of that may not be the same for everybody. And I think that's where it really overlaps with this idea of standards. So part of what we did as a part of those conversations was revisit the reality virtuality continuum from 1994. So this is the original continuum. And we found that it held up really well, but there's some limitations that it had. And so the first one is just a focus on visual displays and hardware. So it didn't extend beyond vision. It was really thinking about just that one sensory modality. Then also it was missing the user experience, and it was missing the concept of interaction that's become a really key part of what we're thinking about in this space. And also a lot of the maybe not goals, but kind of the way it was framed was around this idea of pushing towards realism. And we didn't think that those were necessarily universally true. I think that's an artifact of the time in which it was generated. And so the conclusion we came to is that it's all around mixed sensory inputs. And so now we're thinking beyond vision alone. We're thinking about the user experience, and we're also thinking about maybe not just realism, but maybe some other constructs like coherence and how it aligns with how people are thinking, less about perfectly mimicking the real world. So this is the continuum that we revised. It looks really similar, but we also kind of broke it out into this idea of exteroception. So what's happening, your external senses, so that's vision, hearing, touch, taste, smell, and then interoception. And so that's where we get to what we call the matrix-like virtual environment, because that's really getting into like overriding the brain, essentially. And so I'll pause there and say, you know, that brings up a lot of ethical questions of like, should we do that? But without getting to that point, we'll always have some sensory conflict. And that's because we have gravity, we have hunger. If I don't completely override your brain, no matter what I can do, even if I can perfectly generate some realistic imagery, I'm gonna hold this. Okay, even if I perfectly generate realistic imagery, there's always going to be that conflict once you get hungry, or once you know, you feel the sensation of gravity. So this is just an interesting ethical debate, but also we're not quite there yet, and I'm glad we're not, because of the debates that we need to have. But another thing that we wound up discussing is in a subsequent publication was the importance of terminology and verbiage, because we found that, you know, varied verbiage creates these confusing, arbitrary, often false distinctions between experiences, technologies, and more. And it also, in particular, we thought affects research communities, because we're using different dividing lines, but we're often using the same terminology. And so, you know, kind of in thinking beyond then, do we think a single term can fully describe the continuum? Probably not. I don't think that that's satisfactory, because there's so much complexity. And actually, in the original continuum that was published in 1994, it was not a single axis. It had a taxonomy with three components to it. And so part of what we did in that revisiting paper is we updated that continuum, or we updated the taxonomy that accompanies the continuum. And so we've maintained the extended world knowledge as a component of that, but we also added in immersion, and that's the set of valid actions that are supported by the system. So we often think of immersion as, you know, how much visual imagery is covering up the real world, but you can also think about it in terms of other senses as well. And so then it's more about like, how does the technology support that interaction? And the final one is coherence. So where before they were talking about realism, now we're talking about coherence in terms of how does it align with the user expectations, and how does it fit together in a way that does or doesn't make sense to that user? So thinking about standards and kind of moving forward to the next step, besides, you know, a different way of categorizing things, we need to move from, you know, just taxonomies and categorization into standards, but also, why is that a necessary step? How does it help? I pulled this lovely old quote, I think, from George Box. You know, he said, all models are wrong, but some are useful. I updated that to say all standards are wrong, but some are useful. You know, we can draw these lines in different ways. We can make different kinds of comparisons, or we can bucket stuff in different ways. But at the end of the day, if we do it really well, it still won't be perfect. It may not account for everything, but it can be really helpful in moving work forward. And but there's a lot of challenges to that. And so the biggest challenge that I think we have to be ready for and face is the fact that technology is constantly evolving. And so this is thinking about standardization of a really complex system that's not just hardware, it's not just software, it's a whole system. And those capabilities are changing because there's a lot of investment in changing them. And so that's, even if we make standards right now and they're perfect, we'll have to update them pretty soon because things are constantly changing. Also, different people have different preferred terminology, and that's kind of where that workshop or the panel last year initially started. Was we're using different terminology, but then there's all of this overlap and connectedness, and it makes it tricky. And I think if we can't agree on definitions, then research productivity suffers, because instead of having a discussion about the really interesting and important findings, we're having a discussion about, well, but that's not virtual reality, that's a virtual environment, and they're totally different. And so we need to consider, the way I think about it is strong opinions loosely held. It is helpful to have opinions, it is helpful to have those like kind of internal rules that you're using to define things, but also being receptive to updating those and changing those and kind of, even if you don't love it, kind of being willing to work with the community to agree on a different way of using common terminology across the discipline. And I also thought a lot about, the need for standards. I think the biggest thing is just, if we are going to build lasting knowledge that extends beyond a current iteration of a currently available technology, we need better definitions, and that goes along with standards, because if we don't have standards, people tend to make up stuff. So we need to have those agreed upon definitions that we can use to build that lasting knowledge. That will let us have more comprehensive and better meta-analyses. But again, to do that, we need that common terminology so that we know that we're doing a meta-analysis on something that is, for whatever that research question is, it is the same thing, or we know we're testing different things and comparing different things. Until we have common terminology, it's kind of hard because you have to check for so many different things, but you're also not totally sure that their definition matched yours, and so it makes it really challenging and slow. And then we also need to be able to communicate more cross sector. So some of what we talked about that he revisited is the importance of not just communicating inside of our community, but also communicating outside. And so having standards can help us do that in a way that's systematic and that scales beyond just coming up with a new taxonomy and then hoping that people adopt it. So I've thought a lot about a potential path forward. So this is kind of one proposal for another way to think about standards. And that is leveraging the similarities in how XR impacts human users to accelerate research. And what I mean by that is, we talk a lot about standardizing the terminology for hardware, or what we need to report about the hardware. We do that for the software, but I also think we need to be thinking about what is the change or the experience that the human users are experiencing. And so what I mean by that, we can think about that in different ways as well. And this is not a comprehensive list that I'm about to show, but just kind of brainstorming from my end. We can think about the physical impact to users. And so for headsets, for example, they have weight. That weight puts load on the head. So we can think about it from a physical perspective. There's some challenges with that, and that is that it's very technology specific, because typically AR is designed, and again, AR in quotes, is designed, it's lighter weight because it tends to be more dependent on being worn in the world. It's a little different from VR. And so the technologies may have fundamentally different things, but also it's rapidly changing. And that's something I would say is probably changing the quickest, just because there's so much, every time we get additional capability, people are trying to make smaller headsets that weigh less, because we do know that it affects people. Another way we could consider the effect of these reality and virtuality technologies on users is social. And some challenges with that is that we know that social acceptability shifts with exposure. So as people are exposed to this technology for longer periods of time, their opinion changes. So that makes it really tricky. And also, again, AR and VR are used typically in different ways. They tend to have different functions and are used for different things. So another way we could do, or we could think about it, is cognitive. So focusing on changes in the brain and changes in the mind. That's super complicated, but potentially useful. And so I'm going to kind of propose a way to think about it, just as food for thought. And so, how many of y'all are familiar with the Wiccan's human information processing model? I'm going to show it, but also I don't know. Okay. Well, I'll go through it, and I hope it's not repeating too much. So essentially, this is just about how people process information. So forget technology for a second. The first phase is sensory processing. So there's stimuli in the world. It could be the lights. It could be this. It could just be seeing other people. We process those stimuli. You hear my voice. You see the screen. Those are stimuli. Then you have to perceive them. And so sensory processing is about, like, can I even sense it? Perception is, now I'm kind of gonna make sense of it. I'm gonna organize it a little bit. Then you think about it. And so you actually start to consciously process through that. Maybe you're making decisions about it. You're using your working memory, which just means you're actively thinking about it. But you're also pulling knowledge from long-term memory to make sense of that. And again, figure out what to do with this stimuli that you've been processing. And then all of that kind of supports this idea of selecting how you're going to respond to it. So selecting the response and then actually doing the response. All of this is modulated by your available attentional resources. And then essentially you get feedback from the environment and you continually do this. So this human information processing model is essentially always happening every stage. It's just that you're processing different stimuli. So it's just one way for kind of saying, this is what's going on in our minds all the time. But we can think about this from the perspective of leveraging similarities in technology. So what's the impact of AR on human information processing? And I have some thoughts about that. So is there anybody here that does AR research or that would claim like AR researcher? Okay, we got one or two. Okay, so these are probably familiar. So, we care a lot about the field of view because that tells us where we can put stimuli, where we can put AR content. Depth cues are important because we're interacting that with real world objects and also potentially occluding or being included by real world objects. And then also as the system updates, there's different latency. And so we have to make sure it updates quickly enough to look like it's in the appropriate place in the world. So these are really well known, really well studied, and they affect sensory processing and perception. Or that's what I'm proposing. We also have issues with registration. So that's just placement of content into the world, and clutter, because now we're adding content to an already cluttered world. So typically those are talked about in terms of perception, but they also affect cognition. We also have issues with brightness and color, with AR in particular, because it can blend with the background can blend with the brightness or the color, and so it can change how it's perceived or what it looks like. That also affects attention. And then how the information is portrayed, so how abstract it is. Is it text or is it images, and how blended into the world are those images? That affects cognition, but it can also affect like how people respond to it. So this is just kind of my quick drawing of how AR, ways that we know for sure that AR affects human information processing. But we can take that and we can build on it and think about commonalities with VR. So again, more on the much more immersed side of the continuum, just thinking about occlusion and clutter. We also know that clutter and occlusion issues translate into VR applications. So even though this is initially designed for AR, we can still identify some commonalities. And so extending on that, just to kind of give some more concrete examples, for clutter, when we're thinking about augmented versus virtual reality, in augmented reality, we're adding digital content onto a cluttered world. So the world is real, it's already cluttered, and we're adding more. In virtual reality, we determine how much content is included, but that means we also have to basically choose like how much clutter we'll accept. For occlusion, digital content in AR may block real world objects and vice versa, so they may block it as well, depending on how it's designed. And in VR, we have to decide what occludes and what is occluded. So when we kind of take a step back and think about commonalities rather than trying to distinguish between them, with clutter, essentially the question is just how much content. Now, the main distinction between AR and VR, I would argue, is we have control over the background in VR. We don't have as much control over that in AR. But at the end of the day, it's the same core question that we go back to. And for occlusion, the question is, what is it blocking, or what is it being blocked by? So again, it's the same question, regardless of whether it's AR or VR. And so my whole point with this is just to kind of think through, almost using standards to think about ways that things are also similar. So we can still distinguish between them, but there's value in developing it in a way so that we can also pull knowledge from one to the other. And so we can build and kind of work towards that more lasting knowledge base where we're not having to test every possible iteration of clutter and occlusion for all of AR and all of VR, because that's something it's already not feasible. There's too much work to do because these systems are so complex and they're intertwined in so many different ways. So just to conclude, kind of, I guess I'm a little early, but just to conclude what and summarize a little bit of what I've kind of been saying through this presentation. I think standards can improve communication, and we think about that not just internally in this community and in the VR community, but also externally. It's really useful to have standards so that people know what they're talking about, or can at least, say the same words and get on the same page. But I also think, and I think this is something we don't talk about as much, I think standards can enhance research. And that's especially if we consider ways that it's affecting people. Because I think a lot of times we talk about how to categorize things or how to make those distinctions, but we also can think about it from the perspective of the human and how the technology is affecting people. I think that's a really useful tool as well. So we do have research about, physical impacts. There's research about social impacts. I'm proposing some ways to think about cognitive impacts. I know there's more. This is definitely not comprehensive, but I think it's a different way to kind of frame the problem space and potentially move things forward. But ultimately, kind of the bottom line of the whole presentation is that I do think that we need standards that account for the complexity of XR systems. And so we can't just focus on hardware or software, but we really need to consider all of the different facets. And I think making sure that we're keeping the human in mind as we're doing that, and how it's affecting people is really important. And particularly, it can help us understand where there's some similarities that we can learn from between one technology to another, even if they don't look the same, at face value. They may have the same questions. So that's all that I have. So I'm happy to take questions, or we may need more time. I don't know.
Yeah, thank you. Yeah, okay, yeah, we have 12 minutes, around 12 minutes for discussion. Do you have any questions? Comments? Yeah, so please come to.
First of all, thank you for very impressive presentation. Most XR devices or concept focuses to realism. So how you think that we go beyond realism and try to measure user real, embodiment and experiences? instead of focusing only realism, what the XR devices these days do. What is your opinion?
Yeah, because I do think, you know, how realistic can it be is a good thing to assess and to capture. But I went back to this slide because my best answer to that is still very high level, and that's because we use it for so many different tasks and so many different contexts that it's hard to narrow it down. But I think in here, kind of what I really like about the structure of this taxonomy is that it accounts for coherence, which really gets to what is the user expecting. And so I think that's a good approximation for realism historically, because we were just trying to make it real enough to be useful. But now, you know, we can use avatars, for example, and they can convey emotion, and I don't need it to look exactly like a real person to understand it and to get meaning from it. And so this is where I think, you know, something like coherence, it's like, okay, well then I can use coherence to start to understand, maybe instead of realism, how much it aligns with what the user is expecting and needs from that environment to understand it. So I think about it in the sense of, instead of realism, it's coherence, but also capturing the, you know, how people are interacting with it and how much they can reasonably interact with it. Immersion, that goes to supporting it as well. So I think about it through this taxonomy, but I also think, to your question of like, how do we evaluate that? That's gonna have to kind of be different for a lot of different applications. I think, you know, I don't know that there's, it was happy and now it's not.
Maybe some cable disconnection? Okay.
We'll pause, okay, I'll step away. But to go back to the evaluation piece of it, I think that, I don't think that I believe that there's one evaluation that will solve all, that will answer all questions. But I think kind of some combination of, you know, how much does it actually interact with the world? What senses are we using and how much are we using them? But then also from the user expectation side, how much does it align with what they're expecting or wanting? So yeah, do you have any follow-up questions?
Yeah, that your idea is very good. I'm worried whether industry can, you know, for realism, already industry did many things and they made many devices, XR devices, and they compete each other. But if we look, you know, deeply, all is same. They focus about the realism. But in terms of the measuring the real sensation and experience and, you know, embodiment, this sort of great idea, how you can transfer your experience to the company. They make some devices, tangible devices, like what they did for realism. So this is the idea. If you explain your idea to the industry, how you explain, then help them to make something.
Yeah, well, in fact, I used to work in industry, and so I will say they, you know, a lot of it is driven in places I worked, a lot of it was driven top down. And so it was very driven by what executives thought was important, and you can tell you've already nailed it on the head, hit the nail on the head. You know, some executives think realism is important, and so they're chasing it full speed ahead. But I also think having a flexible framework that can account for, you know, different experiences, different use cases is really critical. And that's something that I actually learned by being in industry, because when you have a really rigid definition and, you know, problems that we came across were like, how is this useful? And it's not always useful because it's more realistic. But I think where industry starts to look back to academia is then how do we think about that so that we can build, you know, they want to build something that they can sell. But they still need that guidance on how do we test that? How do we know that we're in the right space? And so, so I will say like this, I don't think has been adopted by industry, but I think it leads to the conversations that, you know, maybe they're not happening today, but I do think eventually they're going to be happening. Because I think the conversations we're having right now are, you know, what is it actually used for? Think about Meta just released or, you know, published about the AR glasses they have. Like, what are the use cases they have, and how, you know, are they good enough to sell a product? I think they're going to come into questions where what are the users expecting, and how much immersion do we have? How much can the user actually interact with it? How connected is it with the world? So they're going to come into these questions. I don't know that this is the right framework for those applications, but that's, I guess I'll go back to, you know, what I said over here, that, you know, it may not be, I said all standards are wrong, but some are useful. This may not be the direction that they need. But I do think having standards so that they're having the conversation and also know what papers to find, because we search for papers all the time in industry. And also can share out their research for those companies that do it. I think it's really critical to have that standardization. So I don't know that what I'm proposing answers all of that, but I do think that having that standardization is critical to moving things forward.
Great. Thank you very much.
Yeah. Any other questions? Okay. You are the next. We still have time discussion.
Thank you for your presentation. I loved your framing and the sort of thinking. And I'm thinking that yes, it's difficult to divide virtual and augmentation and P and A, but also I think that there's a two-dimension of reality because I'm a psychologist, so I think that the reality for people, as you show in the process and information processing, reality is in the mind, not the physical world. So, but some types of real or AR, for example, the digital twin use. And we need physical reality to construct. So I think that there's the reality has a two-dimension, physical dimension and a psychological or something like the mind or something. Like, how do you think about this kind of?
Yeah, I mean, I think I agree with that. I want to like think about it more. So part of what I like to do is like, how can I prove it right? How can I prove it wrong? And I think that's a good way of approaching things. But yeah, I mean, I think I've heard it said perception is reality. Like what I'm perceiving, what I'm, you know, processing is my reality. And there's some things that can be physically measured or verified. And so I guess I think that's where like there's kind of those two axes and kind of how you're proposing it. But even in, you know, even when I can verify it, I think sometimes those things are like, even if I can, I'm thinking about like optical illusions where a straight line looks crooked. I can verify that it's straight, but it still looks crooked to me. And so I think that having those two, like kind of two types of reality makes sense, but also like they can sometimes be in conflict and I can be aware of it or I can be not aware of it. And so I think that's another kind of tricky space that we have to be thinking about it. And so where I kind of see that connecting in is we can use these, you know, reality, virtuality technologies to support one or the other, or to make them align better, or to make them not align at all. And so I think it's just a different kind of nuance to the space that we're in, and I think it really captures the complexity of the space that we're in.
Thank you very much.
Hello, I'm Ibrahim Bukhari from Virginia Tech. Thank you so much for the interesting presentation. It was super interesting because just a couple of months back, our lab had a very heated discussion over what augmented reality is when someone called Meta Ray-Bans as AR headsets. So this was very interesting to know how there are different frameworks that try to classify these technologies. I'm just interested, I want to clarify that from what I understood, you mentioned that psychological impacts is one possible way we can help explain these or standardize these, right? I wanted to know your thoughts on using physiological impacts for the same purpose.
So I guess when I'm thinking about physiological impacts, I think it's so intertwined with the task or the activity that it's hard to separate as its own dimension. And so like the reason I have physical is like just putting on a headset affects the user. We can measure that, we can quantify that in different ways. But when you're saying physiological, there's, you know, we can think about gaze behavior, we can think about heart rate. Those are intertwined with also what's happening in the brain, like what's happening in cognition. And so, so I don't know, I guess I don't think of it as a separate thing. That doesn't mean, I mean, I could be wrong. But I think of that as a way of kind of understanding the whole experience. So I think it's really like physiological really gets to, you know, your heart rate's changing, not just because you put the headset on, but because of what you're seeing and how you're processing it. And so I think that's really getting more towards like, how can I consider the impact of this whole experience rather than just like the technology itself. So I think I need to think about it more, but I think that's a really good question and one that's worth like diving into and thinking about in depth.
That makes sense. I understand your point that it would be hard to isolate the impact of technology with those, but
maybe you could, I don't know.
Yeah.
And go Hokies.
Thank you.
Maybe we can have one more question. Okay. Satisfied?
Where's your work?
Actually, I have lots of questions, but later. So the next time that we see again. Thank you so much. Next, invited talk given by Hiraki-san. Hiraki. He has yes, now so double duties. One is industry side, and another is academia side. So I believe he can, how to say, alleviate or eliminate the gap between industry and academia. Maybe sometimes through the standardization activities or his own activities. Okay.
Okay, so thank you for the introduction. So I'm Hiraki from the University of Tsukuba and Cluster Metaverse Lab. So yeah, and today's my talk title is the latest trends of large-scale metaverse platforms and optimization. So yeah, and so I'm so as the person described and I have the joint appointment with the University of Tsukuba and the private company that is the Metaverse platform in Japan, and that is the name Cluster Inc. And Cluster Inc. is the branching the Metaverse platform Cluster. So yeah, and maybe yeah, I'm discussing about the both sides from the private company platform side and academic sides. So before starting my presentation, so we want to thinking about what is the metaverse for especially so the terminology of the metaverse. So that is the right buzzword, and you know and for the side of the big standardization. So that word is very confusing about us, including researchers. So yeah, and my summary of my opinion is what is the metaverse is the very roughly understanding is the life experience in a virtual computer generated world. So please imagine movie, Real One or the some post share or something, that kind of the science fiction movies. So the people is doing the right experience in such kind of the competitive world. So I think that kind of the lifestyle is the very illustrating what is the metaverse. So, for the technology side, that's very difficult to decide the precise meaning of the metaverse, but just for the imagining the rough image is the right. I think that's very easy to understand what is like. And but for the more precisely, so some the researchers and some the metaverse related people is the proposing components of the metaverse. So and they say there is the 8 conditions for realizing the ideal metaverse. So yeah. And they say the existing metaverse platforms are being developed towards this ideal situation. And this advice is also expected to focus on these kind of elements. So the exist permanent place, of course, that's very important. So if the metaverse platform is collapsed, so the people is so that is means the world is still collapsed, then that's very difficult situation for the people in that world. So and the real time is also very important. So the real living in the real time world. So the real time experience is very important. And the another thing is limited users. So yeah, of course the limited users is very we can make a very small society. So and the other thing is economy. So maybe so there is some seeing the lack of discussion of the economy, but so if we are doing the right experience, so there is of course there is an economic activity in that society. So that's very important thing. And the borderless experience are little bit not straight meaning, but so if for example, so if the world is not unlimited borderless experiences, and that kind of the world is the immersiveness is a little bit wrapped, and that is an important issue. So that means borderless experience means such kind of the border is the reduce our immersiveness. So and that kind of the borderless experience is very important. And the other thing is the interoperability. So that is of course very important. So we are discussing more very frequently in this, also in these workshops. And another thing is contribution from the companies and individuals. So this individual is very important. So from the contribution from only from the company. So that is like very game, like something, and that is just for the companies as by God and provide some very interesting contents to the individuals. So but for the metaverse, so the contributions from the companies and individuals, and that kind of the ecosystem is very important for the metaverse. Yeah. And another thing, embodiment. So so the metaverse is used for the human, and of course that's kind of the interface is very important. Yeah. And but this kind of 8 perspectives also are very difficult to understand. So then I recently summarizing what is the metaverse is like these 3 aspects, that is embodiment, spatiality, and experiences. Yeah, and that's just of my opinion, but the role of the metaverse is to integrate these 3 elements, that embodiment, spatiality, experiences, 3D spaces, and embracing the development of these the experience devices. Yeah, and this kind of and of course there's also that center thing of that area is this platforms and 3D spaces, and then plus the real joining that 3D spaces to some devices and interfaces. So of course that is the very important thing, and but just for the interface and platform, so that is the very just for the platforms, and there is like nothing. And also of course their contents and experiences is the defining what is the metaverse. So yeah, and we summarizing these 3 components is very equally very important for the metaverse. Yeah. Then I will be introducing our platform Blaster. So maybe the Blaster is the very famous Japan, but for the worldwide, so that's not so such famous. So I will introduce what kind of our platform and what is this, and yeah, and Plaster is one of the Japanese largest metaverse platform, and the very special point is our platform is can enter using the VR HMD and smartphone. Smartphone includes Android and iOS, and PC is the Windows PC and Mac. So the very like that kind of large device platform is our very special point as a metaverse platform. Yeah. And so the business is our view to enterprise business and platform business. So as you know, so the metaverse platform business is very difficult because the monetization is so difficult situation in all over the world. So yeah, but so for the platform business is that is the very important side, but so we mainly make the money for this enterprise business. That is supposed to be business, and so we are doing some very special promotion events or promoting some stuffs from getting the order from the companies and then doing such kind of enterprise business, and then we are investigating that benefits to the platform business. That means that is for the users, customers. And the very the special point of the Plaster platform that is also in the very chat is also same situation, but the very active user-generated content in that kind of metaverse platforms. Yeah, for the situation in Plaster, so the number of words created and published by creators and in tens of thousands of words is uploaded. Yeah, so in our platform, the official word is very a few number of the official words like the 10 or less than 100, I think. Yeah, but all other words, tens of thousands of the words is made by the individual users and uploaded to our platform. So that is almost made almost as the user-generated platform, I think. And then using that kind of word as a template, so thousands of events are held annually, every day. Yeah, and with audience of millions of audiences. Yeah, that is the very the user-generated content-based ecosystem is already made in such kind of platforms. Yeah. So for the community, yeah, it's more daily on Plaster platform. Yeah, and like music events or the book reading clubs or of course the academic conference also held in our platform. So yeah, and that's very interesting situation is the happening this kind of metaverse platform. Yeah. And so I'm a researcher, so using this platform, so we're doing some research project using such kind of commercial metaverse platform. So I want to introduce some of our recent the projects using the metaverse. Yeah, and first project is named Reader. So that is the large scale VR experiment platform. So yeah, and that is a very simple motivation is trying to make the virtual reality version of the crowdsourcing platform like Amazon Mechanical Turk or something, and we try to make the large scale VR experiment platform for collecting the users' behavior logs and then questionnaire responses. So this kind of the experiment is regularly we are doing in the lab based, and so we really have to gathering the participants and then, but for the online based experiments, we are very easy to gather participants, and then the process of the experiment is completely automatically. So that's very easy to do such kind of VR experiments. So yeah, and we also confirm the feasibility of this experimental framework using implementing some online experiments such as the very basic VR the experiments like the condense effect, 3D version, sweet throw, and hand direction, something. So, and then results says that kind of the result is not completely same results from the previous papers and the discount, but of course we can gathering the rank about the 500 the participants, and then we doing such kind of the experiments. So that's very powerful tools for the online VR experiments. Yeah. Then, related to that project, so we, of course, we are the platform and we have many output log data. So then we are trying to make such kind of extracting such kind of log and then sharing that data to the collaborating researchers. So yeah, and so that is the heat maps of the users take time in our clusters will be more. So that kind of data is very easy to get from our the AWS server. So then we offering the service the very limited collaborative institutions, yeah, because of the privacy issues. Yeah. And then we also make the driver software the modulating input. So that is why if we make very custom software if using the lab-based experiment, but for using the commercial-based metaverse platform, so we cannot, rewrite the program that kind of the software on the metaverse platform. So then, but sometimes we try to modulate the input information for the VR experiment, like the suit haptics or the redirection or something, In that case, so we developed the OpenVR compatible input modulation driver to enable the various, avatar or the posture expression. So yeah, and we already implementing this kind of the software and verify the coordinate fixing and see control display ratio modulation of device input can perform the real time within this kind of the metaverse environment. Yeah. And the other project is the named Magic Ident. So that is the AI assistant that automatically generates the script program of the related items in the metaverse platform for using the natural language prompts using LLM. So yeah, that is for the very newbies for the scripting users. So in that case, so in such kind of metaverse platform, we can make the custom items for the using in the metaverse platform world. But if the newbie for the program is they cannot write program using the PC or something, but of course they can say the intention of what they want to do in the world. So then we automatically generate a script program and then attaching items and automatically according to the world. So then we doing some evaluation. So we do some tasks and we doing some free tasks and then we had to read, but almost 86% of the participants can do the very simple task. That is the writing on the boxes and rotating. So such kind of the task is the task one. So, but this task is a little bit difficult for the very newbie programmers. But the 86% of the participants can do such kind of the tasks. So that's very powerful tools for the reflecting the intention of the users to the metaverse world. And the other project is the Magic Graph. So that is also using generative AI system, a collaboration with generative AI system and metaverse platform. But we try to make a system that generates the functional 3D objects for metaverse platform from natural language input. So yeah, and then users say something about what we want to do. So in this case, the video shows in this case a chair. So the chair's image is automatically generated from generative AI, and also we automatically make 3D models using this based on these 2D images, and then user can adjust how to sit that chair using the Gizmo 3D UIs, and then automatically put the scripting program like this. So this is the chair and this is the rideable item is something, such kind of the information is automatically added to the items and automatically uploaded to the metaverse platform. Then user can see as soon as possible, just make the 3D models. So that kind of is also the same the motivation as Magic Item. So that is for the newbie for the metaverse platform. So they cannot motivate, but they want to make something. So we try to make their intentions to And we also evaluated the 7 experts and 51 general users, and 51 general users for the newbies, and 7 experts is our companies, the CZ engineers, and then they say, that's of course the compared to the handcrafted one, so that is a little the shiny and something, but that's okay for the general usage, and then 51 general users. Even for the first time, users successfully created very complex interactive objects, including the triggers, something. And another topic is the name navigation dictionary. So this is the we presenting in this Iceland conference. Maybe the day after tomorrow. And if you have some curiosity, so please hear our presentation. So, but this is the on-demand conversational AI agent combining LLMs and spatial metadata. So regular AI agent is based on LLM, but for the metaverse specialized AI agent can use the spatial metadata based on the metaverse platform. So we are merging this basic LLM information and spatial metadata information of the world. So this kind of the lack of and our motivation is to trying to address the lack of effective navigation support. Because in the cluster, so there are many user-generated contents in the metaverse platform. So if we make the general one, so they cannot effectively guide in such kind of user-generated world. So then we made such kind of the AI agent system, and we do the experiment in our cluster platform with about 200 participants. So based on the online experiment. So and the result says it can significantly improve the state duration and exploration time in the world using that kind of AI agent. And PC and where HMD, so there is some different effect is happening with so if we have some choices, so please hear the presentation in the main conference. And the other project is the name panel tree. So that is the searching the photo spot in the metaverse world. So so we are using the stored photographic coordinate data, and then for the training phase, so the photo taken from the user is scored as 1, and the random capture image is scored as 0, and we running the network, and then if the inputting some images, so we can scoring some, right? So if that is very similar to the photo taken by user, so score is very similar to 1. So and that is not real image, so score is like 0. So and maybe in that case, so score is, if the score is very high, so that is the right very capturing the special information about the world. So so this kind of the photo spot searching system is very effective for the making thumbnails of the world. So then the important point is that we can enable the world evaluation before world publication. So what kind of searching such kind of thumbnail images is very difficult before the opening the world. So before opening the world, so the world creator is the which kind of the images can show the very effectiveness or the very interesting point of the world. So but before the opening and publicating the world, so we can search the very nice spot in the world. And then finally, I want to share the perspectives on standardization based on metaverse platformers. The first thing is avatars. So maybe the VR presentation is already done. So maybe it is the second time for about the VR talk. So the avatars are the embodiment of oneself in the metaverse. So that is very most important point for the metaverse. And the VRM is widely used in Asia, including Japan. So the platform is also using this VRM the format. So that's very powerful one. But in the standardization efforts, so the Asian people prefer the anime style one, is kind of the avatars, but North American people is prefer the more photo real one. So that is very difficult point for the making the standardization about the avatars. And the second point is clauses. Yeah, so we are not including the clauses. So in the avatar, is have some clauses in such kind of format, but the very important point is clauses it's crucial for engineering function, and but sometimes we want to convert the clauses, but currently the skeleton model of the bodies vary from each avatar. So then, we can switch the clauses. And so if we want to switch the clauses, so maybe should create from scratch for each skeleton. So yeah, that is the old culture made like the made style. So that's very difficult for the switching clauses using such kind of avatar formats. So yeah, the standardization of the clothing is very needs to progress alongside of the standardization of avatars, in my opinion. Yeah. And another standardization topic is platform, of course, platform. Yeah. So that is the as an interoperability issue. So yeah, for example, so the first and right chat is not connected, and but for in the future, so the connecting and easily switching this kind of platform is the create such kind of mechanism is definitely needed for the smoothly moving the various metaverse worlds. So yeah. And another topic is 3D asset. So I call this issue as the cost of unity. So yeah, yeah, instead of offering the convenience, the developing unity, so 3D assets are now defined unity assets file format. Yeah, and many platforms, including VRChat and Cluster, is also in this situation. Yeah, and the 3D asset specification entirely developed unity. So and that's not, in my opinion, that's not a healthy situation. So yeah, other range is under reading everything, but of course, teacher is very big sense. So yes, standardization of 3D asset specification cannot be achieved without this kind of existence of standard game engine, open standard game engine that supported. Yeah. And in summary, so I showed the latest trends of metaverse platform and aspect of standardization, and I talked about this metaverse and introducing cluster and this project using motion metaverse, and then aspect of standardization. Yeah, thank you for listening.
For your talk, we will have around 10 minutes for discussion. Is there any question, comments?
Thank you for the interesting talk. I think life in the virtual is, I think you define the metaverse. I think yeah, a life experience is in the computer world is metaverse. I think the life includes work, and I think if and also you are mentioning the economy in the metaverse, and I think if the many people want to start business in the metaverse, is much more a good situation for expanding the metaverse world. So what is there any your activities for promoting the starting business in the metaverse? Can please introduce if you have some example.
Okay, thank you for the great question, and that's very important topic in metaverse. So that is the called as the virtual economy or metaverse-based economy. But that kind of economical thing is very important for the growth of the metaverse platforms. And yeah, but the important point is if regularly, so for example, so some creator can make the avatars and avatars clothes for the accessories avatars, so they can very easily make money for selling that kind of the contents. But for the regular, So there's all of the person is not creative, but the other regular user cannot make money in this regular situation regularly. Yeah, that is all metaverse platform is the same situation. Yeah, and I think that's a very big problem. So then that means the very a few users can make the money, and that means the money is in the economy is very few, and then so that means the regular person is converting real money to the virtual money and buying such kind of avatars and accessories something. So that is not a healthy situation. So then that's why we try to make this framework. Yeah, that means user can make money using the free time, their spare time in the virtual spaces. So then they can get the virtual money as doing such kind of the joining experiment, and then they can use that money for buying something in the virtual space, in metaverse spaces. So that kind of the technique, not a technique, but that the flow for the make money as a normal user is very important thing for the growth in the virtual economy. Thank you.
Thank you very much. Very nice presentation. For make a standardization for embodiment and for specialty, maybe some industry and diversity of the commercial platform, they are worried this sort of standardization maybe make some limitation for them. So what is your opinion? Make a standardization, but not make limitation for their creativity and other things. What is your opinion?
Thank you. That is very important and hard to answer the question, but I try to answer, but generally and that's my personal opinion, but I think our platform companies think so. So if the normal standardization is trying to restrict this, the freedom of the development of the platform, so so we trying to contribute the standardization, not for the restricting so hard. So that means if we joining the standardization committee, so we try to make some opinion. So that is not for the regular.
But they don't believe. How you can make sure? Usually they don't believe and they feel that standardization make a limitation. So how let them to feel better?
For one thing is the power of the government. So, but that is not healthy thing. But the one side that is of the government, and then restriction. Force restriction is also one thing. But but another thing is the patient communication between the standardization side and transformer side is very important. So yeah, of course, the standardization side is trying to more nicer world and nicer platforms. So that I think the seeing side for the future of the metaverse is completely same, in my opinion. So then patient communication is needed for the understanding each other.
The role of government is very important.
Yeah, I think so.
And I have one suggestion. User embodiment, cognitions, and special interaction, core metrics of the metaverse standardization. So it would be better we explore cross-platform framework to evaluate these components. I didn't see any research for cross-platform for evaluating, for some sort of user embodiment, cognitions, special interactions as a core platform. This cross-platform evaluation, that would be good the as my suggestion for future direction.
Thank you. So that's very nice and very important aspect. Yeah. And to tell the truth, so we already starting comparing the community generation situation between the the difference between reality and the clusters. So yeah, that's very important. Yeah, of course, the user specification is completely different from these kind of platforms. And the other side, so that we also started some research using the difference in immersiveness for the VRHMD and PC and smartphone. So such kind of the difference of the device is also very important for the quality of the advanced experiences. So yeah, this is I think it's very big important area of the for the metaverse research.
Thank you.
Thank you. Maybe we can. Okay, one more question.
Thank you for your nice presentation covering academia and also commercial side. I have one question. Would you show the magic craft technology? I wonder that once the objects are generated, then there was an interaction of digital characters and the objects. So how can you generate the digital characters motion? Is it instantly generated by AI or a built-in motions? I wonder that.
Thank you. A very good question. So in the state of the magic craft research, so that kind of the motion, maybe that is right affordance of the items is the manually crafted from the user. Yeah. But that I think we completely understand that is the very problem for this kind of workflow. So we are starting for the research automatically understanding the affordance and putting some making some script program for the understanding how to use or how to see or how to read or something. So that kind of understanding that kind of the affordance is in ongoing research. Yeah.
Okay, I wonder that. Yeah, thank you so much.
Thank you. Other question?
Okay, so let's thank the again.
Thank you. Thanks so much.
So thank you for staying until the end of the XRStand workshop. So as mentioned at the start of the workshop, this committee was created to connect academic research and standardization work and to build stronger collaboration between academia and industry. So by promoting shared standards, tools, and data sets, we aim to enhance both research impact and interoperability across XR domains. So the XRStand workshop was organized as the first step in this effort to bring together researchers, industry experts, and standardization members for open discussion. So we've had one keynote, 2 invited talks, and 10 accepted posters for sharing valuable perspectives on how standardization can support the XR field. So we will now conclude the workshop with a brief discussion to synthesize these ideas and consider next steps. So you'll see 3 guiding questions. So first, how can research tools, methods, or data sets be shared and developed into standard-ready forms? And second, what kinds of collaboration or open activities could help continue these efforts beyond ISMAR 2025? And third, how can XR standards include accessibility, ethics, and social responsibility? So these are our main topics for discussion today. So please feel free to share any comments or questions, even if they are not related to those questions. So do you have any comments or feedbacks about under these questions? I think I can. You can. Oh, yeah.
So I see that we also have like data sets over there, but I didn't see any posters that were presented that have data sets in them. I wonder if there were any submissions for data sets that were not being included.
I'm not sure, but like, about this like specific data set, I think there's no like really specific data sets, but like some posters are mentioned about the importance about the like large scales of data of sharing. So that's why I included the words data set, and also like there's many standards items are try to cover the data set. So that's why I mentioned about it. Yeah, but does any standard posters really include the like real large scale data? Oh, yeah. Oh, yeah, there is this. Yeah, yeah, there it is. Yeah, can you explain a little bit about it? Yeah.
Okay, that poster, we included some kind of data set. We hold a competition, data set competition. So yeah, it includes some kind of data set, the evaluation metrics, also the whole benchmarking process. So yeah,
There was, and I think you raised your hands.
Yes.
Yeah. Yeah.
So for data sets, I have some opinion, but we are the platformer, so many data and so we can, to tell the truth, we try to make such kind of huge data set, provide huge data set, but the problem is in the metaverse platform is cannot make money for making such kind of data sets. So that means we cannot assign some human resources for making such kind of data sets. So yeah, that's a very difficult situation for providing them. So that because for making such kind of data sets, for example, the privacy issues and then the management issue is happening, but compared to such kind of issues, so the platformer cannot make some benefit from such kind of activity. So I think that's a very difficult problem. But if there is some collaborator for making some data sets, so we are very happy to the effort to such kind of activities. So for example, actually in the real world, in Japan, the NTT data or NTT, Docomo, which is a carrier company of the mobile phone, and they are selling the log data of the users. From where to where they are moving, where to where, and also the transportation company, JR, are selling the also the log of the NFC, the mobile money card. So maybe using that analogy, so Cluster also can do the good business by selling the data. Maybe.
So is there any other? Okay.
Thank you for three very challenging question for discussion. For the first, I think we need some sort of platform which can share open platform, especially the industrial data set is lacking. Because in academia there is some data set, but in academia usually data is limited and we cannot too much believe to the accuracy. But for industry, since they have enough budget, so some platform, open platform, and for XR standard, I would suggest we can make some XR standard from which not exist. So there is no such a XR standardization. For the third question, there is some sensorial data. Sensorial data set is sensitive because it is related in body and inside body. When we are going for ethical issue, especially for sensorial data set, we should make some sort of clear and some sort of more limitation for sensorial data. As well as for standardization, for ethical issue, sometimes instead of making a standard, we need make some proactive ethical, how to say standardization, or because if something happened, then we are going to do standardization. It's too late, but we should have some sort of proactive before something happens in advance. We try to recognize it and make it as a form of a standard.
For sharing your thoughts. So I also agree about all of your comments. So I also think like basically industry and academia also both meet like kind of similar problems, because like metaverse basically contains the human or avatar complements and also the spatial components and also etc. All means very security or privacy, diversity problems. And I think like there's some good some points that industry can solve easily, and also like there's some other points that academy researchers can solve easily. So that's why I think like we need more like continuous collaboration between industry and academy, and to support like and to solve those kinds of problems, and to develop the XR standardization and the research methods. So yeah, I think yeah, we are running times. So yeah, if you like to continue these discussions, like please visit our standardization committee booth during the conference. Yeah, and you can meet the committee teams, the related projects, and learn how to get involved in future activities. So we are also looking for new committee members, so who want to join our efforts and help shape the next steps of XR standardization. So if you're interested, please come talk to us, and we're very happy to have you join us. So before we close, I'd like to thank everyone who made this workshop possible, and thank you for the keynote speakers, invited talk speakers, and also all the host presenters, and also very thanks to committee members who support today's event. So thank you again for everyone for being part of this first XRStand workshop, and let's keep building the future of XRStand together. So yeah, so thank you. So this is the end of this workshop. And now before we finish, let's take a group photo together. So please come to the front, and is there any, no, there's no like participant. So yeah, can you like come front and let's take a group photo and finish our workshop.